Hello guys, I welcome you back to Global Education Zone. And today in this episode, which is the fifth episode of Crash Physics for SS3, in this episode we are going to be dealing with electric field, which is part 3, conduction through liquids and gases. Now, when we talk about electric field is a special part of physics because it deals with the part of physics that is beyond mechanics. So we have mechanics and then we have electricity. Electricity deals with the part that is totally beyond mechanics. You will recall that in during the times before the 20th and 19th century, there was nothing like electrics. Yes, physics was composed entirely of mechanics, but today now we have electrics and even optics. Though optics is kind of like an age-long subfield of physics, but this electric field it's very important because it's a recent field and there are a lot of exciting things for us to talk about here. So, in this episode, we are going to be dealing with the conditions under liquids, or under which liquids and gases conduct electricity, and then we're also going to be talking about the behavior of charges or charge carriers in liquids and gases. Now, spoiler alert: those charge carriers in liquids and gases they are called ions. So those ions they are positive and negative types. The positive ones are called cations, the negative are called anions. But actually, in yes, that's what they are called. But in electrolytic cells, the positive charges go to the negative anode, then the negative charges go to the positive anode. So that is just a snippet of basically what we're talking about today. Let's move on with today's course. So we're talking about a voltameter. So in a voltameter, it is the setup where electrolysis happens. So an electrolysis can be simply explained as the breaking down of or the decomposition of a compound by the means of the electricity that passes through it. So in this case, you have a setup, you have a battery supply, and it is basically a circuit. And this liquid, which is in this voltameter, is called the electrolyte, and this electrolyte it happens to be a conductor. So you notice that actually it completes the circuit from the battery supply to the battery supply. So and you know that you need a conductor for electricity to flow, and electricity only flows in circuits. So basically electrolysis is the chemical change in a liquid due to the flow of electric currents through the liquid. So when electric current flows through a liquid, it causes chemical change. So and then you have two poles of something in the electrolyte. So as we were saying, this is basically a voltameter, and you have your circuit. And then let's talk about something else. We have the random movement of ions in an electrolyte. So um basically, it's tied to ionic theory, which states that in an electrolyte, the ions are moving very freely and singly. So that means in an electrolyte, you have your positive and negative ions, they are moving randomly, and the only time they align to move in a particular direction is when you pass a positive charge or a unit positive charge through them, and that positive charge goes through that electrolyte and it leaves. So that creates a current electricity that flows through the electrolyte, and then the ions will now align themselves in the correct order. So in that case, that means the negative ions will be attracted to the positive anode, and then the positive ions will be attracted to the negative anode. Negative anode, yes. So in this case, our positive ions are the cations, negative ions are the anions, and then the positive anode is the positive electrode is the anode, and then the negative electrode is the cathode. That is in an electrolytic cell. So you'll be able to interpret the corresponding alignments of the ions in that case. So basically, this is talking about the random movement of ions in an electrolyte. So let's move on to the aspect that talk about the dynamic movement of ions. So which is what I just explained, that when you set up an electric circuit, you are basically causing it to have a dynamic flow of electricity. So now you have your cell, your key, your resistor. This is basically an electric circuit. And one thing you can, if I ask you to tell me something that's unique about this, is that this is a circuit that is completed by an electrolyte. So it's a liquid or gas that conducts electricity. That's what you call it. So next, let's talk about the electrolysis of water. So in electrolysis, we have the sample electrolysis of different things like water. This is the apparatus used for electrolysis of water, and then it consists of a funnel tube. Your oxygen collects above the anode because it is kind of it is as a result of the negative ion. Then your hydrogen collects above the cathode because it is as a result of the positive or hydrogen ions. So the electrolysis of water, in summary, it produces two volumes of hydrogen and one volume of oxygen in this kind of setup. So then we have the electrolysis of copper sulfate solution. So in this case, this is solution of copper sulfate. If you've done fundamental chemistry in secondary school, you will have been taught about the formula for copper sulfate. It consists of copper elements, sulfur, and oxygen. So the symbol for it is CuSO4, and in this case, when it is electrolyzed, it's decomposed. That means the positive part of this compound moves to um, the negative electrode, and then the negative ion in this compound, which is the SO4 2 minus, it moves to the positive electrode. So in this case, that is in the first case, that was copper we're talking about in the first case. Then in the second case, that was the sulfate ion. So, and they will be recovered as depending on the three factors. So those three factors are basically depending on the concentration of the solution, the relative position of the ions on the electrochemical series, and then the nature of electrode used. So these three factors, they are very important. They affect each of these discharge. So you can check out my chemistry course in this channel. I've done a video on electrolysis and I've explained most of these concepts in details here. So this is the physics part of electrolysis. We don't need to go in much depth. We only need the fundamentals that concerns the electrolysis, because the reason why we study electrolysis in physics is because in a battery, it's an electrolytic reaction is set up. So the fact that your battery can produce voltage for you is as a result of the electrolytic setup in there. So you have your electrolytes like your and you have your polarizer like your manganese dioxide, you have your copper sulfate and all the rest, ammonium sulfate and all the rest in that battery. So those mixtures, they react chemically together due to their chemical nature, and then that reaction leads to electricity. So I didn't mention this earlier, but chemical reactions can also produce electricity. That is what is known as electrochemical cells. So electrochemical cells, they are also known as batteries. So they make use of chemical reactions to produce electricity. So in the other case, we have it as electrolysis, which is the production of the use of electricity to produce a decomposition of a chemical compound. So I hope you understand that concept. So here we have the concept of electroplating. It's an application of electrolysis. Now, earlier I explained that in fundamentals you have the fact that your compound is being decomposed, right? So basically, in this case, we also have your potassium um, silver cyanide solution, and this is the electrolysis here, and it is a conductor of electricity. So this electrolysis, they conduct electricity because of the ions in them. They have moving ions. So, and that is one properties of ionic compounds. So they form ions. But if it were a covalent compound, it will not consist of ions. So there are compounds like that are covalent and do not conduct electricity. So that is chemistry. That is not physics. We're not dealing with that in depth today. So we have your silver rod and your spoon. So basically, in this case, you have your potassium silver cyanide. So in this case, this is set up um, to dep- to deposit silver on the spoon. So this is kind of the process. It's kind of like a small scale of how these things are done in the industrial scale. So in the industrial scale, you have very large equipment, very large facilities to electroplate all these metals. So this is the process of electroplating. We also use it in when you are trying to electroplate a metal like copper. When you can use this electrolytic cell setup to electroplate copper and prevent it from rusting, and that is known as cathodic protection. So I hope you understand this concept. Next, let's talk about Faraday's laws of electrolysis. So in this case, the first law of electrolysis states that the mass of a substance liberated in electrolysis is directly proportional to the quantity of electricity which has passed through the electrolyte. So what it simply means is that the first law simply means that the more electricity you pass through an electrolyte an electrolyte, the more mass of substance that will be decomposed or that will be deposited at the anode and at the electrode. So simply what that means is that those electrodes, they are the points of contact of the electrical circuits to the electrolyte, and the more you pass electricity through the circuits, the more of that compound in the electrolyte, the more that compound or element is brought out of the solution. So we have the second law of electricity, which states that the mass of different substance deposited or liberated by the same quantity of electricity are directly proportional to the chemical equivalence of the substances. So in this case, this simply means that the mass of different substances, they are proportional to the amount of charges required to deposit a mole of them. So basically, for example, copper has a charge of 2, so that means two charges are required to liberate 1 mole of copper. So that means you need 2 Faraday. So a Faraday is basically a measure of electricity, of electric charge that is required to decompose and deposit 1 mole of a substance. So that shows that the more the charges on an ion, that means the more the electricity requires to deposit it, and the less the charge, the less the electricity. So that shows that for univalent elements like hydrogen and chlorine, you will need the least amount of electricity to deposit them. Then next, let's talk about the electrochemical equivalent, which is ECE. So the electrochemical equivalent is of a substance is the mass of that substance deposited by 1 coulomb of electricity or by 1 ampere in 1 second. So this is simple to understand. So it's simply the amount of a substance that is deposited by 1 coulomb of electricity in 1 second, and that is a constant for a particular kind of element. So we have the graph versus time of electrolysis. You can see it's a straight line, which means that it's directly proportional to the amount of charge with time. So basically, that is basically what we are dealing with in this episode. We also have the setup to verify Faraday's second law of electricity. So this is a setup involving 2 voltmeters, and it's kind of shows the that concept. So basically, I hope you've understood this concept of electrolysis. Let's talk about cathode rays. So when I talk about cathode rays are negatively charged, and they are produced in a cathode ray tube. And these cathode rays, they are applied in our CRT televisions, which were those used in the early days of technology. So cathode ray tube technology of televisions, they were very very large, and they worked on the principle of cathode rays, whereas whereby you heat a metallic filament to a high temperature, and then you produce electrons, and these electrons are deflected to the anode, which is kept potentially negative to the cathode. So we also have the definition of cathode rays by magnetic field. So these deflections, these cathode rays, they are fast moving streams of electrons, which can be deflected by either electric field or magnetic field. So there are other properties of cathode rays, like they also make a paddle wheel turn in the when it's placed in their direction. That shows that they have energy, and also they produce heat. So these cathode rays, they are energetic electrons, and they are very much applied today in a lot of our applications. So you also have the thermionic emission from hot filaments. So this is one principle of cathode rays. And then you have the diode valve characteristics. So this diode valve, it was a valve that was being used before the invention of the diode. So this diode valve is basically, it can be studied using a circuit. So in this case, a diode is basically a special electric component that allows electricity to flow in one direction only. So because of the fact that in a diode, your anode is made to be relatively positive with respect to your cathode. So that is why electrons move to it. So because electrons are negatively charged, so they are attracted to the positive part of the circuit. So this is basically the basis of operation of a diode. So basically, that is all we're covering today in this episode. I know I've covered a lot in this episode, but due to time constraints and because it is getting dark, so I have to complete the episode before something else. So I hope to see you next episode. Thanks for watching.